If you want to see more videos like this one, then please feel free to subscribe to my science channel. Hello everybody, my name is Craig Bennett, and today I'm going to get into a video on string theory. So, as far as things goes, I want to mention a few things. String theory is a theory, so it does not mean that it's fact-based at all. And theories do change in some slightest sense over time. So, because of that, I'm going to stick with the core of string theory. Second, I want to mention, and this is very, very important, a lot of scientists out there, even Neil deGrasse, and I'll show you a clip of this a little bit later. A lot of scientists are trying to get away from string theory because it's proven to not really be the case. It seems to be more of a pipe dream. And I'll explain a little bit more about this towards the end. So as far as that goes, what is string theory? So first things first is we have things like Newtonian laws, we got Kepler laws and stuff like that. And these laws of physics explain the world that we can observe around us without tools, without instruments, without microscopes and all the other stuff. However, when you get into the quantum world, things change quite massively. You can have things in the quantum world where they can be in two places at once. You can have things in the quantum world where there's teleportation. You can have weird stuff, like you even observing anything in the quantum world with your own eyes. Like if you have instruments that's looking at it, it does one thing, and then when you turn it back, it does something else. So even our own constants is messing with the quantum world, and we don't know why. Like, you don't see it where we have instruments looking at the sun, and then and when we look at the sun, it does one thing, and then we turn back, it does something else. That doesn't happen, but in the quantum world, it does. And even having instruments looking at stuff, it does change things into some aspect. So with that, a lot of people in the science world doesn't like the fact that there's two separate different rules when it comes to these different worlds, and there has to be some glue in between, and that's where string theory comes in play. So with string theory, if you zoom in on any item, you'll get atoms. If you zoom in and try to get smaller than that, you get electrons. Zoom in smaller than that, and you get quarks. This is our limit as far as what we can see and know about the small universe. So if you zoom in even further than that, string theory says that you get strings. Now real quick, as far as what it looks like on the screen, you might be seeing, oh, that looks more like a donut. Well, same thing with atoms. We actually don't know what this stuff looks like. In fact, strings is a theoretical thing altogether. We don't even know if it's there. But with atoms, we don't know what it looks like at all. That's just a theoretical thing, easy for us to understand. And the fact of the matter is, all we care about is how it interacts with things on the outside. Same thing here with strings. If that is the case, that's there. We don't know what it looks like. It doesn't matter. It's just a matter of how it interacts with everything on the outside. So where did it get its name from? Because obviously, it doesn't look like strings. So where it got its name from is simply if you pluck a string on a guitar or, deal with a violin or whatever, the strings will vibrate. The sound comes from the vibration, which messes with the air and so on. So basically the vibrations interact with everything on the outside, and that causes a chain reaction for something to happen. Well, same thing here. Is the vibrations of the string in the string theory is that tells the outside world how to interact with it and how it should interact with the outside world. So basically you get something like the sun. So if you take a look at the sun, there is nothing between us and Earth. So for all we know, take out dark matter, take out all that, because even that's, we're not really 100% sure that there's a lot of that, and there might be gaps in that between us and the sun. Take out all that, right? Well, the thing is if you just take a look at what we have, there's a pure vacuum, nothingness between the sun and Earth, up to a certain point, because atmospheres and whatever it may be. Well, how is it that you can have gravity travel through that nothingness? So how is it that you can have something travel through nothingness? And that's where the problem really comes in play. And that's where string theory is trying to solve that. Is the sun is more dense, it has more strings, and there is something in the theory that's called messengers. Something with more messengers is able to interact with outside objects one way or another, more so in this case telling it to attract to the given major dense object. So it's an explanation on these type of things. And everything else, like if you take a look at carbon, you take a simple carbon atom, get a whole bunch of them, and if you line it one way, you get a diamond. If you line it another way, you get something else. So why is that? Why is something know to align itself one way versus another way? So string theory is supposed to basically be the glue for that little bit. Here's where the problem comes in play, is string theory, for it to work, the math behind it says that there needs to be about 10 to 11 dimensions. Fine. Well, the fact of the matter is how can you test for that? Because the fact of the matter is if you take a look at math and whatever it may be, math lies. If you're in school and you want to tick off your teacher, and they're a math teacher, tell them that math lies and they want to argue against you, use this. And keep in mind, I got a background in NASA and with, all the other stuff. Bees mathematically shouldn't be able to fly. And elephants mathematically should be able to fly. Explain that. So math lies. Most of the time, 99% of the time, it's true and whatever. But there's a finite moment where it does lie at certain points. So we need to have something a little bit more solid than math, than simple math questions saying that this is how something works. So that's where the Hydrent Collider comes in play. So for those of you who don't know, Hydrent Collider is basically a big ring, a vacuum ring, and they basically shoot two particles at each other almost at the speed of light. And when they hit each other, they break apart and exposing all the inners and whatever. So we can actually study a little bit further. Well, here's where this theory comes into play. In theory, what happens is if those particles hit each other, then there should be a loss of energy or a gain of energy. So for those of you who don't know, energy is a constant in our universe. It can never be lost or gained. So if there is a loss of energy, if you measure the energy before and measure the energy afterwards, if there's a loss, then that means that some of our energy went into another dimension. If there's a gain, then some of our energy came in from another dimension. This ain't panning out. So there's problems with that. Now this is not like a death nail in a coffin, because this might not be like the ultimate way of testing things. It's just what we know now. There might be an actual better way, or the thing has to be tweaked in some form or fashion to get better results from it. So it's not a death nail in a coffin saying that, string theory should be thrown out the door. Otherwise you wouldn't hear about it, and I wouldn't be talking about it. So the thing is there's been so many tests on string theory, it's basically looking like a pipe dream, no matter which way you want to take a look at it. There's many scientists believe that there's multiple dimensions, multiple universes, and all the other stuff. Yeah, maybe, but the fact of the matter is we really require evidence to have, be able to document it and say this is the fact instead of this is our opinion. There's a major difference between fact and opinion on this one. So you're now getting to the point where you have famous scientists that are saying the following.
Curious, what's your opinion on M theory or string theory? That is to say, do you feel that it could be the, theory of unification, or is it just a theoretical pipe dream, in your opinion?
Right now, it's smelling pipe dreamy, I think. I've been following these guys for 27 years. And every 5 years, I ask them, how much longer? And they say, just a couple more years. And I ask them every 5 years. Just a couple more years. So I did this in 1982, 87, 91, and so something's wrong here. And they said, well, it's a hard problem to unify all the forces of the world and put everything under one equation and make it all the beautiful vibrating strings. It's hard. That's the answer they give, rather than, we're just too stupid. General relativity was hard. It was done by one man. It took him 9 years. We had experimental proof 3 years later. I'm ready for another idea from them. But they're the only game in town, and they're really inexpensive. You just buy a few pencils for them, maybe a sharpener. They're good to go. Throw in a laptop. Fine. They're not in anybody's way. So I'm okay with that. Okay? But I'm no longer their champion. I used to speak praises of them. I don't, and just because they want it to be elegant doesn't mean the universe agrees. Right? Most efforts to layer onto the universe our own sense of what is elegant have failed from the very beginning of thinking about the universe. So I'm losing my confidence, but I don't volunteer that fact. It has to be asked of me, as you just did. Okay. The last two questions.